Welcome to the story guide. Temperature, thermal energy, and particle motion. Understanding the basics. To comprehend the intricate relationship between temperature, thermal energy, and particle motion, we must first grasp the fundamental concepts of each. Temperature. This is a measure of the average kinetic energy of the particles in a substance. Kinetic energy is the energy of motion. When we say something is hot, we mean its particles are moving rapidly. Conversely, a cold object has particles moving slowly. Thermal energy. This refers to the total kinetic energy of all the particles in a substance. It's a measure of the total amount of heat energy present. Particle motion. This is the movement of the tiny particles that make up all matter. These particles are constantly in motion, vibrating, rotating, and translating. The connection. The key to understanding these concepts lies in their interconnectedness. As the temperature of a substance increases, the average kinetic energy of its particles also increases. This means the particles move faster, leading to an increase in thermal energy. Visualizing particle motion. To better grasp this concept, imagine a pot of water on a stove. As the water heats up, the water molecules gain kinetic energy. They begin to vibrate more rapidly and move around more freely. This increased motion is what we perceive as heat. States of matter and particle motion. The state of matter, solid, liquid, or gas also influences particle motion. Solids. In solids, particles are tightly packed and vibrate in fixed positions. They have the least amount of kinetic energy. Liquids. In liquids, particles are more loosely packed and can move around each other. They have more kinetic energy than solids. Gases. In gases, particles are far apart and move rapidly in all directions. They have the most kinetic energy. Heat transfer. Heat energy can be transferred from one object to another in three ways. Conduction. This occurs when heat is transferred through direct contact between particles. For example, when you touch a hot stove, heat is conducted from the stove to your hand. Convection. This occurs when heat is transferred through the movement of fluids, liquids, and gases. For instance, the warm air rising from a radiator and circulating throughout a room is an example of convection. Radiation. This occurs when heat is transferred through electromagnetic waves. The sun's heat reaches Earth through radiation. Applications in everyday life. Understanding the relationship between temperature, thermal energy, and particle motion has practical applications in our daily lives. For example, cooking. We use heat to transfer energy to food, causing its particles to vibrate and move faster, leading to cooking. Heating and cooling. We use heating and cooling systems to control the temperature of our homes and workplaces, affecting the motion of air particles. Weather. Weather patterns are influenced by the transfer of heat energy between different parts of the Earth. In conclusion, temperature, thermal energy, and particle motion are fundamental concepts in physics and chemistry. By understanding how these concepts are interconnected, we can better appreciate the world around us and make informed decisions about energy use and environmental impact.